The signal arrives clean. That is the first problem. 22 hours across interstellar space. The Deep Space Network locks onto Voyager 1 without drift. Carrier stable. Timing stable. No interruption anywhere in the chain. Then the telemetry opens. Power readings spike past operational limits. Memory values begin overriding themselves across the monitor. One subsystem appears dead for 3 seconds, then normal again. Engineers send another command into the dark. 22 hours later, Voyager responds correctly. The spacecraft is still obeying instructions. Only the information inside the signal has stopped behaving like a machine. The signal arrives exactly when it should. 22 hours across interstellar space, straight into the Deep Space Network. Clean lock, stable carrier, no interruption. Then the monitors begin flooding with telemetry that makes no sense. Temperatures spike beyond survival limits. Power systems report impossible behavior. Memory values flicker across black screens faster than engineers can read them. Entire sections of the spacecraft appear dead for 1 second, normal the next. But Voyager 1 still answers commands. Engineers send instructions into the dark. Wait almost a full day for the response. The spacecraft turns correctly. Systems react correctly. The signal comes back on time.
Telemetry is holding steady across all bands.
That should not happen.
We are green across the board, Dr. Chen.
If the onboard computer is failing, commands should stop working. If the transmission is damaged, engineers should lose lock entirely. But the connection remains clean while the meaning inside it collapses.
Critical warnings across the board.
Reroute all
The signal
powers to the
stays
primary guidance
clean.
system.
The
Isolate
telemetry
the
inside it does not. For a moment, nobody answers the telemetry. There is no way to check what Voyager 1 is actually doing anymore. Voyager 1 is over 14 billion miles away now. Everything depends on the signal. And now the signal is contradicting itself. Every corrupted transmission still arrives exactly on schedule. The next transmission looks different.
The velocity data is spiking.
Same
past light
spacecraft,
speed.
same
The life
telemetry
support
system,
metrics are green
but the
across
corruption
board.
changes
We need
again.
diagnostics now.
Deep Space Network dishes turn slowly toward the same point in interstellar space, while engineers place telemetry windows side by side across their screens. One readout shows broken memory values. Another shows stable systems with impossible temperature swings. Minutes later, the pattern changes again. It refuses to fail the same way twice. At first, that almost helps. A damaged subsystem should fail consistently. Engineers can isolate consistent failures and trace them back to a source. But this corruption keeps changing faster than the explanations do. Every time they think they recognize the pattern, it mutates. A clean explanation survives for a few hours, maybe a day. Then the next transmission arrives and contradicts it. The signal arriving from 14 billion miles away is still strong enough to lock onto cleanly. Still, commands return correctly. Only the meaning keeps changing. And that begins shifting suspicion away from the spacecraft itself. Because operators are no longer just questioning what Voyager is doing. They are starting to question whether the signal is changing before it even reaches Earth. Then the telemetry begins settling down. Not completely, just enough for the numbers to start making sense again. Engineers isolate one of Voyager's flight data pathways and start rerouting information through another onboard route. Commands leave Earth. 22 hours later, the response comes back. The telemetry can finally be read again. Green engineering values stabilize across the monitors. Temperature readings hold steady. Power levels stop flickering. Sections of memory that looked impossible before suddenly begin behaving like normal machine data again. And for the first time in days, the telemetry behaves like a machine again. Voyager 1. Rerouting telemetry through aging onboard systems makes sense. The probe is still running on 1970s computer memory after decades in space. Corrupted memory feels like the kind of damage people expect from something that old. And the repair appears to work. If damaged memory caused the corruption, rerouting the telemetry should stabilize communication. And briefly, it does. The room changes after that. Conversations slow down. Engineers stop chasing shifting patterns and start treating the spacecraft like a repairable machine again. The signal feels stable again. For a moment, the problem finally seems containable. But the confidence returns faster than the proof does. The next distortion appears in the middle of a stable read. Green values holding steady across the monitor, then suddenly fragmenting into broken binary noise before snapping back again. But not in the damage pathway, somewhere else entirely. Engineers start isolating systems unrelated to the original fault. The repaired telemetry route is still functioning. Commands still cross the 22-hour gap correctly. By every earlier assumption, the corruption should be contained. Instead, the corruption spreads beyond it. Teams compare transmission logs against spacecraft schematics while the room goes quiet again. For a moment, the failure still looks containable. Then, another clean telemetry stream fractures mid-read. The failure is no longer staying inside the damaged system. Voyager 1 no longer looks like a spacecraft with one damaged system. Now the corruption is appearing in systems the repair never touched. And the monitors start filling with something else. Spacecraft diagrams fade behind visualizations of magnetic fields and interstellar plasma. Engineers stop asking which onboard component is failing and start asking what Voyager is moving through now. No human has ever operated this far beyond the solar system before. Which means nobody knows how much of the distortion is damage and how much is simply the distance itself. The farther Voyager moves outward, the stranger the signal becomes. One faint signal line moves across the monitor. The carrier signal still holds. After everything, Voyager 1 is still speaking from interstellar space. The transmission crosses nearly a full day of darkness before it reaches Earth. Antennas lock onto it, computers decode it, telemetry appears on the screen. But the telemetry never becomes fully trustworthy again. Some values look real, some do not. Some failures vanish before they can be verified. Others spread into places that were never damaged at all. Every decoded message arrives mixed with values engineers can no longer verify. And there is nothing left to compare the signal against. No astronaut will ever reach it again. No camera will fly beside it. No human being will physically inspect what Voyager is doing out there. If distance only weakened the signal, the information inside it should still remain consistent. Instead, the farther Voyager travels, the less certain the signal becomes. The signal never disappears. It just becomes harder to trust. The mission slowly stops looking like a normal engineering failure. A struggle to decide which parts of the signal still belong to reality and which parts belong to the distance between worlds. Human technology keeps functioning. Human certainty does not. And somewhere beyond the heliopause, Voyager keeps transmitting into a region humans may never fully learn how to measure.